Welcome to This Explainer. Today, we're setting the stage for a really incredible journey into the mind of a guy who literally defied every odds stacked against him. We are going to decode the life, the deeply human flaws, and the absolute genius of Stephen Hawking. You know, this isn't some fairy tale of magic or miracles. It's the very real story of a fiercely stubborn thinker, a man who was locked in a physical cage, yet somehow managed to map the extreme boundaries of time and space.
Okay, let's dive into this, because right off the bat, Hawking's life is framed by these cosmic, almost poetic coincidences. Get this, he was born on January 8th, 1942. That is exactly 300 years to the day after the death of the great astronomer Galileo. And then, in this beautiful twist of history, he took his final breath on March 14, 2018, which just so happens to be Albert Einstein's birthday. It's honestly almost like the universe perfectly bookended his life with scientific royalty.
Now, there's this brilliant core contrast that really defines this entire story. On one side, you have a physical body that was rapidly paralyzing. It was freezing into a stone-like state where he couldn't walk, couldn't write, and eventually couldn't speak a single word. But on the other side, an entirely unbound mind. While his muscles failed him, his intellect was traveling to the deepest, darkest, most violent corners of space, all without ever needing to board a spaceship.
And then there's this number that absolutely stunned the medical world. 55 years. When he was just 21 years old, doctors delivered a grim prognosis, basically telling him he had maybe 2 or 3 years left to live. Instead, he outlived that terrifying expiration date by a staggering 5.5 decades. He completely shattered every single medical expectation they had.
Section 1. The Defiant Slacker and a Frightening Diagnosis.
To really understand how this incredible journey started, we have to realize he wasn't some born saint with a halo. In fact, during his youth at Oxford, he was a deeply flawed, defiant slacker who treated the world like a machine to be dismantled. He actually admitted to study less than 1,000 hours over 3 whole years. I mean, that's less than an hour a day. He joined the rowing team as a coxswain purely to cure his own boredom. He kind of looked down on the students who studied hard, basically coasting entirely on his raw, arrogant genius. He was so lazy he barely scraped together a first-class degree, relying purely on his soaring confidence during a final oral exam.
But you know that carefree arrogance? It came to a crashing halt. In 1963, at age 21, he was diagnosed with a rare form of ALS. His brain simply stopped sending signals to his muscles. Fast forward to 1985, a tracheotomy to save him from pneumonia completely destroys his natural voice. He goes from using a little thumb switch to control a computer to eventually relying on an infrared sensor mounted on his glasses. And that sensor? It tracked the tiny twitches of a single cheek muscle. He was quite literally locked inside his own body.
So the crucial point here is how he adapted. Using that cheek sensor, he could only type at an agonizingly slow speed. We're talking roughly 15 words per minute. Sometimes it would take him 10 whole minutes just to form a single sentence. But surprisingly, this became a secret weapon of sorts. Because he couldn't waste time on long, rambling thoughts or physically writing out complex equations on a chalkboard, his mind became brutally concise. He forced himself to process incredibly complex mathematical geometry entirely in his head.
Section 2. Proving the Big Bang. By the time he was at Cambridge, his stubborn drive to work, fueled partly by needing to support his new wife, Jane, pushed him to tackle the ultimate question, the origin story of our universe. He dove right into the era's biggest cosmological debate. On one side, you had the steady-state theory, which argued the universe has always existed and just constantly creates new matter to fill in the gaps as it expands. Well, Hawking absolutely despised this idea. It made zero logical sense to him that matter would just magically appear out of nowhere. He passionately supported the rival idea, the Big Bang theory, claiming everything started from one infinitely hot, dense point, and he wanted to prove it using hard math. But to actually prove it, he had to grapple with a totally mind-bending concept, the singularity. Picture taking the entire Earth and crushing it down until it's the size of a single grain of sand. Now, it would still weigh exactly the same as the Earth, but it would take up practically zero space. That is a singularity. The density becomes infinite, and all the known laws of physics just completely break down.
So, working with mathematician Roger Penrose, Hawking did something brilliant. They already knew that collapsing giant stars form singularities, what we call black holes. So Hawking thought, wait, what if we take the math of a collapsing star and just run it in reverse? If the universe is expanding today, rewinding the clock means it must have started by exploding outward from a single singularity. And with their 1970s singularity theorem, Hawking triumphantly provided the mathematical proof for the Big Bang.
Section 3. The black hole paradox.
Having essentially proven how the universe began, Hawking becomes massively famous. But his legendary ego was about to clash directly with established science, starting with this concept called entropy. Entropy is basically just the measure of disorder. Think of a perfectly clean bedroom, right? Over time, dust gathers, clothes get thrown around, and it naturally gets messy. Things in the universe naturally move from order to chaos. Well, a young scientist named Jacob Bekenstein suggested that black holes must have entropy, meaning they have a temperature. Hawking initially thought this was absolute nonsense, because a black hole is a trap. Nothing escapes, so how could it possibly emit heat? To stubbornly defeat his rival, Hawking did the unthinkable. He married two completely different rulebooks of physics that had never been successfully combined before. He took general relativity, which is the math of massive things like stars and gravity, and combined it with quantum mechanics, the math of tiny things like atoms and electrons.
He took these combined rules and applied them directly to the event horizon. Just imagine standing right at this terrifying cosmic boundary. The event horizon is the absolute edge of a black hole. It is the exact point of no return where the gravitational pull gets so intense that not even light, the fastest thing in the universe, can escape.
And this brilliantly illustrates what Hawking discovered at that edge, and it completely shocked the scientific world. See, quantum mechanics says empty space isn't actually empty. Tiny pairs of particles constantly pop into existence and destroy each other. But if they form right on the event horizon, the black hole's immense gravity sucks one particle in. The other particle is left without a partner to destroy it, so it escapes into space as radiation. This just blew Hawking's mind. It meant black holes aren't completely black. They leak radiation, they slowly evaporate, and over trillions of years, they actually eventually explode. Ironically, he proved his rival Bekenstein was right all along.
But this led to a terrifying problem for physicists: the black hole information paradox. See, quantum rules state that information in the universe can never be permanently destroyed. Think about it like burning a physical book. Theoretically, you could collect every single particle of ash and smoke, put it in a supercomputer, and reconstruct the text. But Hawking argued that when a black hole evaporates and disappears, all the information of the stars and planets that fell into it is destroyed forever. This claim broke the most basic rule of quantum mechanics and literally horrified the scientific community.
Section 4. Fame, Ego, and Flaws.
Now, this massive debate really reminds us that science is not some sterile, emotionless process. It's a deeply human endeavor filled with pride, bets, and personal struggles. Hawking's soaring fame brought his monumental arrogance right to the forefront. He fiercely refused help from others, even when he would fall out of his wheelchair and injure himself. He placed these petty, stubborn bets against rival scientists regarding black holes. He even wrote his massively successful book, A Brief History of Time, not just to casually share knowledge, but specifically to pay for his daughter's education and his crazy medical bills. All of this, combined with his total physical reliance on his wife Jane, created intense marital strain, eventually leading to their divorce in 1995. He wasn't a flawless saint. He was a struggling human trying to balance severe disability with global stardom.
But despite his personal flaws, his philosophy was deeply inspiring. He once noted, "We are just an advanced breed of monkeys on a minor planet of a very average star, but we can understand the universe. That makes us something very special." He firmly believed that because the law of gravity exists, the universe can literally create itself from nothing. He was completely unapologetic in his view that a creator wasn't necessary, but he believed human curiosity was absolutely sacred.
But true science is about facts, not ego, right? In a stunning climax to a scientific journey, at the 2004 Dublin conference, Hawking publicly swallowed his massive pride. After 30 years of stubbornly claiming black holes destroy information, he stood up and admitted he was wrong. He explained it using this brilliant analogy. It's like putting a massive encyclopedia into a paper shredder. The paper and ink, the actual information, are still there, they aren't destroyed, but they are completely garbled and impossible for humans to read. He even bought his rival a baseball encyclopedia just to honor his lost bet.
Section 5. A holographic legacy.
Even in his final years, when he was almost entirely paralyzed, his mind delivered one last revolutionary concept. In 2016, he introduced the soft hair theory. He proposed that when something falls into a black hole, its information doesn't actually fall deep inside. Instead, it gets permanently stuck on the absolute edge, the event horizon. It acts like a 2D hologram storing 3D information. Think of it functioning almost exactly like the tiny data chip on your modern bank card.
Zero-energy photons, which he called soft hair, act as a holographic hard drive, keeping the universe's information safe right at the edge of the abyss.
Stephen Hawking absolutely showed us that the human mind can conquer almost anything, but vast mysteries remain out there. Based on the incredible foundations he laid, do you think humans will ever actually cross a black hole or maybe even achieve time travel? Let that profound thought linger and keep questioning the vast unexplored cosmos around you.